Hi, this is Daryl Barnes with BarnesBasics, and right now I'm doing another problem, a kinematics problem, a motion problem. I was on a nature hike and I got stung by yellow jackets. And this problem 4A, B, C, and D, all of these are based on that. I got some video from it, and so if you want to look at Hymenopterous Wars 2015 on my playlist, kind of fun to be thinking about it now instead of then. I just did a problem where I was vacating an area, so I was already moving. Then I got stung, and then I accelerated, and I determined how far I moved. But this question is only dealing with how far I moved during my period of acceleration. So it says, what was his rate of velocity at the end of his 4 seconds of acceleration using only data from the period of acceleration? Because I had an initial velocity before I began accelerating. So my initial velocity was 1.0 meters per second headed in the direction of south. My acceleration was 0.45 meters per second squared in the direction of south. The time at which I uniformly accelerated was 4 seconds, and the distance I moved during that time was 7.6 meters. So everything here has 2 sig figs. This has 2 sig figs because the 0 is after a whole number. It's also after a decimal. So we'll make sure that we put our answer in 2 sig figs as well. So I'm trying to find final velocity. So that's the question I'm trying to find, and we're going to use a final velocity equation to determine this. So when we begin filling this in, we say that the initial velocity 1.0 meters per second squared fits to substitute for VI squared, and we add this to the acceleration of 0.45 meters per second squared. I'm kind of squeezing here to make sure I don't run out of room. And the displacement was 7.6 meters. We don't want to run out of room. That's not very cool. So before we calculate, I want to talk to you just a little bit about these words down at the bottom. In the TI-84 Plus, if you turn it on, and then if you hit mode, you will see that you can nav pad through this and make sure that you have normal, fix 6, decimal, real, degree, and math print selected. To get out of that, you hit second and quit. For the TI-Nspire, to make sure that you have these values for the document, if you click on, then we would select home, and we would select settings. So we use our nav pad to go over to settings, and let's do document settings, and then let's make sure we have float 6, degree, normal, and approximate. Tab all the way down to the bottom, hit OK, and we are going to use the document at the very bottom left, and that has the multiply, divide, minus, and add key. We're not going to use the scratch pad when we do this. So we are going to use a math page, just a document page to do this. So there is a video at the very first of this Kinematics play series. It explains in detail how to do this. All right. So let's start off with this equation here. We'll use the TI-84 Plus. Now, we'll take the easy pickings here first. And we know that 1 squared is 1. So it is going to be a little bit tricky because we're going to have 1.0 meters squared divided by second squared. We're going to square the units as well. But when we put these other values in, let's hit clear. We will say 2 multiplied by 0.45. multiplied by 7.6, and let's hit enter, and I will get 6.84 meters squared over second squared, meters squared over second squared. Add these together, I have VF squared is equal to 7.84 meters squared over second squared, I need to get VF. So I need to take the square root of this value, 7.84 meters squared over second squared, to get the value. So let's do that. In my calculator, I already have the 6.84, so I'm going to say plus 1, enter. Okay, I've got 7.84 in my calculator. Very good. Gets a little bit tricky right now, but not too tricky for people like us. We're going to take the square root of it, and then we're going to use the answer that we already have and not have to enter it in. So what we would do is we would hit the second key at the top left, and then hit the x squared key, which would get us the radical sign. Then if we hit second again and hit the negative sign, which is the answer, hit enter, and we get 2.80. And it's going to be in 2 sig figs, so let's just go ahead and say 2.8 meters per second in the direction of south. Let's just go ahead and say that. And let's see if we can verify this with our TI-Nspire calculator. We already know 1 times 1 is 1, so we're good here. Let's try this expression right here. 2 multiplied by 0.45 multiplied by 7.6. Let's hit enter. I got 6.84 plus 1, enter, is 7.84. Now in the TI-Nspire, the radical sign is a little bit different, and we're not going to use a second key, we're going to use a control key. It's a little yellow one on mine right here, but it's a little round one. So we're going to say, to get the square root of 7.84, we're going to say control x squared, which gives me the radical sign. And then I'm going to say control answer, which pulls up 7.84. And once again, I get 2.8 meters per second to the south. So that successfully answers what was my rate of velocity at the end of my 4 seconds of acceleration using only data from the period of acceleration. That was kind of nice. It wasn't too jumbled up. I like this problem a little bit better than the first one as far as just neatness. It's important to be neat for your teacher. Be neat. Circle your answers. I don't know if you have to put a happy face. That's just something I want to put. Good job, everybody.